In the name of God, the most gracious, the most merciful, peace be upon you and God's blessing. We are going to have a look at solved problem number 5.2 from the Steel Design Handbook. It is required to find the plastic moment M sub B for a given section W10x60. The steel is A9092 steel. For the sake of comparison, two options are used for the solution. The first option is option A, in which we consider the given W section as composed of 3 plates. For the given W10x60, the data of the section is as follows. The flange width is 10.10 inch and the overall height is 10.20 inches. The flange thickness is 0.68 inches, while the web thickness is 0.42 inches. The section is represented by 3 rectangles, as we can see in the sketch at the right of the slide. In the next slide, due to symmetry, the plastic neutral axis will be located at the mid-height of the given section. We will represent the 3 rectangles as half a section, which contains the upper flange rectangle area and the half of the web. The area of the upper flange is equal to 10.10 by 0.68 equals 6.86 inches square. The area of the half web is equal to 0.5 by 8.84 by 0.42 equals 1.8564 inches square. Adding the two areas together, we will find that the total area over 2 equals 8.7244 inches square. For Y1, the distance from CG of the area A1 to the plastic neutral axis, it can be found as equal to 4.76 inches, which is the half of the overall height, from which we deduct half of the upper flange width. While for Y2 distance, it is equal to 0.5 by half of the overall web height. To find Ybar, or the point of application of the compression force, we will estimate the moment of areas about the plastic neutral axis, or the sum of A by Y. A1 by Y1 equals 32.6920, while A2 by Y2 equals 4.103. The sum of AY divided by A1 plus A2 equals 4.217 inches. The distance of CG from the top of the flange can be found to be 0.88 inches. The Y-bar distance is the distance from the point of application of the compression force to the plastic neutral axis. The complete W section is drawn with two arrows representing the C and T forces. The Z sub X, or the plastic section modulus equation, is equal to A total divided by 2 by Y bar multiplied by 2. The NB value is the product of Fy by Z sub X. Z sub X value is equal to 73.63 inch cube. The yield stress F sub Y is 50 KSI. The value of MB equals 50 multiplied by 73.63. Divide by 12, we get M sub B equals to 307 foot kips. The compression force C equals to the tension force capital T. Each equals A total divided by 2 multiplied by F yield equals 436.22 kips. We will move to the next slide. After checking table 1.1 for W section, there is no Y bar, or the distance from the plastic point to the top of the flange, we need to use WT 5x30 section, which will lead us to the second option, B. From the next slide, which shows the other part of table 1.1, the Z sub X value of W10x60 is 74.6 inch cube against our estimated value of 73.63 inch cubed. The next slide shows the data for WT 5x30. Our W section can be expressed based on option B as two WT sections 5x30. The width of the flange of the WT section is similar to the flange of the W section, but the height is half of the W section height. The area of the WT section equals 8.84 inch square. There is a difference between Y sub B and Y bar. Y sub B is the distance from the plastic point to the top of the flange for the WT section. If we multiply Y sub B by the flange width, we will have half of the area of the WT. We use the Y bar distance since we need the distance from the CG to the neutral axis. From the next slide, we will reassemble the two WT sections and introduce a sketch for the forces acting. We can see that YCT distance equals 10.2 minus 2 Y sub B, so the value is 8.4532 inches. Z sub X can be found for the W section as equal to half of the area of the W section by YCT, or 7/2 by 8.4532 equals 74.623 inch cube. Multiply by F sub Y and divide by 12, we have M sub B equals 311 foot caption. Thanks a lot and see you in the next video. God bless you all.